Welcome back to Networking Fundamentals. We're going to get started right now with Module 5 and continue our journey through understanding wired and wireless networks. So let's go ahead and get started. Alright, so let's take a look at our agenda here. Like I said, we're going to cover understanding wireless networking. And so that means we got to understand wireless devices and wireless standards. Alright, so let's talk about wireless networks. For a wireless network to work, all devices have to be connected through a wireless network adapter. And so that's a little bit different from a wired one that you and I saw earlier in one of our modules. I think that was module 2. And those devices, they connect through radio signals to a wireless access point. And that wireless access point, of course, is a central connecting device that's capable of sending and receiving data with radio signals as well, right? And those access points still use Ethernet cables, right? They're connected to the internet, for instance, by Ethernet cables or copper cabling, all right? So let's talk a little bit more about wireless network adapters. They enable connectivity between any device and wireless access points, right? And they work simply by translating bits into radio signal. And all that happens is that the radio signal, they modulate, so they go up and down, and that's how they represent zeros and ones. That's a little bit different from the way you and I represent zeros and ones in binary data. Wireless network adapters also take a lot of different forms, right? So most laptops now have internal adapter cards and onboard wireless adapters too, which means that they just go onto your motherboard, right? But there's still external adapter cards and also USB adapter cards that allow you to connect wirelessly. Wireless access points, they come in many different forms as well. Oftentimes they're located in your home router or your Soho routers at your home office or your small office. And wireless access points, like I mentioned earlier, and I hate to hammer this down too much, but they're connected to switches, right? And we do have dedicated ones that are specifically for the purpose of sending and receiving data in a large organization. Now, they may be hiding in the ceiling somewhere above you right now, depending on where you're watching this video. But wireless access points, they simply do that same thing. They translate bits into radio signals, and then they send it or receive it, right? And they do a good job of receiving them and then translating them into electrical signals that are required to transmit data to a switch or to a router. Another technology that we haven't talked about is a wireless repeater. Now, wireless networks are limited in how far a wireless signal can transmit. So if you think about the range of a wireless access point, it only goes so far, right? You could actually place a wireless repeater here at the end of a network in order to extend the signal range of a wireless access point. Now, repeaters do this by reading the signal coming from the wireless access point, and then they go ahead and repeat it and send it out. Of course, we have to make sure that the data finds the device there, right? And similarly, it reverses that process in order to make sure that our device, if connected to a repeater, is able to send data back onto the local area network and onto the internet. Next, bridges. Bridges function a very similar way to repeaters. Bridges sit in between two different wireless local area networks though. And what they do, just like bridges in real life that connects two different sides of a ridge or maybe a gully or something along those lines, bridges, in this case, bridge two different networks together, right? And connect them together. And this is actually known as bridge mode. All right, so let's talk about wireless standards. For wireless networks to function, all of the devices, all of the wireless adapters have to use the same wireless networking standards. There are a number of different networking standards that define wireless communication, and they're commonly referenced as Wi-Fi. Okay, now those are the standards, the body of standards that dictate the data transfer rate, right, or the connection frequency and more of wireless communication. Now, the standard, however, is commonly referred as 802.11. Okay, so let's take a look at the chart I have over here on your right. Okay, now an odd little fact, just so you know, is that 802.11b was the first wireless standard created, right? It was first to market rather, right? And then shortly after followed A. What I want you to notice is that these two are really the key to understanding this whole table. Okay, B came first, so its data rate was slow and its frequency was low, and then came along A, and it was fast and its frequency was high. Now, I sort of like to think of it like the way genetics work in biology, right? So I like to think of G as sort of like a child of A and B. So if you look here at the chart, you'll see what I'm talking about. I always think of G as inheriting 54 megabits per second from A, whereas it inherits 2.4 from B. So while B is slow and low, A is fast and high, and so G is going to be fast and low. Okay, so if A and B were parents, right, they would pass along those traits to B. And of course, that same type of analogy doesn't necessarily work for N down here. But N just gets faster with 600 megabits per second. And then, of course, it uses both frequencies, right? It uses 5 megahertz and also 2.4 megahertz as frequencies. So hopefully that analogy helped you to remember the difference between those standards. All right, so 802.11n is the standard that is commonly used right now. There's actually one that's newer than that. I believe that is 802.11ac, but it's a standard because it's fast, right? But there's also a couple of other factors too. It supports multiple antennas. So if you have a wireless router at home, simultaneous connections and data streams can flow into that wireless router, right? And there's something also called frame aggregation that it supports, which is just sending 2 or more frames in one transmission. So the same radio signal can double your bit rate. Right now, there's also something called channel bonding, right? And so channel bonding, we're not going to detail here. It's a little beyond the scope of this course, but you don't want your channels sitting right next to each other because that can cause some problems when your data actually transfer. Okay, but if you're using 2 channels in combination with each other, you're able to send twice as much data as possible. And that's really quite a positive thing for wireless communication. So let's talk about wireless network topologies. So similar to wired networks, there are different ways to connect devices on a wireless local area network. Now, recall that these arrangements are called physical topologies, right? And just know that when you're connecting wirelessly, the physical location of your device does not necessarily always matter, okay, as much as they do when you're using a physical cable, right? So there are 2 common ways that you can connect devices wirelessly. There's ad hoc mode and also infrastructure mode. All right, so what is ad hoc mode? Well, in ad hoc mode, devices are organized in something that is very similar to a mesh topology. So if you can recall from when we were talking about a mesh topology, notice that every single device is connected to each other in the topology, right? Clients communicate directly with each other. So this is an example of a peer-to-peer network like we had talked about previously. Now, ad hoc mode is used less commonly than the next mode that we're going to feature, which is an infrastructure mode, right? And this is probably the one that you're using right now, even in your house or if you're at work or at school. Infrastructure mode is the most common way to connect wirelessly. And what happens, like we've been talking about this entire time, is that your device is going to connect to a wireless access point, which then is connected to a cable that trails off to a switch and off to a router. When clients want to connect, they use a service set identifier. So if you're connecting to the internet through an internet service provider, and you have a home router, you're probably connecting by using a service set identifier or a SSID right now. Before a device can access the network, clearly you have to try to connect using that name. But you're also going to have to authenticate with a password. And that password is going to basically prove to that wireless access point that you belong on the network. So one of the things that's not often talked about with wireless communication, at least not in general conversations, is that though it's convenient, it's not always secure. And that's because the data is just traveling through the air, right? The radio signals just travel on through the air. And that means that anybody that can access that data, right? It's publicly available out there. And if you have proper technologies, you can actually access it. And so we have to protect our wireless communication, and we do that by using encryption protocols. The table at the right is going to detail a couple of different wireless encryption protocols for you. Now, you may be familiar with a few of these, and you may be using some of these at home. What happens with encryption is that we scramble data to make it unreadable to hackers. And we do this using keys. And the size of your encryption key is going to dictate how strong your encryption is, right? So the longer the key, the harder it is for someone to hack your data. So if you're using a 256-bit key, it takes a lot longer for a computer to be able to try to hack your data and figure out what messages you've been sending back and forth. In contrast, the 64-bit key probably isn't going to be super secure right now. All right, so lastly, we're going to talk about 802.1x. It's a standard that's used to secure wireless communication. Now, there are three basic components within this type of setup, all right? So first, you got the client computer, which is called the supplicant. And then we have a wireless access point, which is called a network access server. And then you have a radio server, which is going to be responsible for authentication. So what happens is in a 802.1x, is the supplicant is going to contact the wireless access point, and it's going to request access to the network. The wireless access point is then going to contact the radio server way over here on the right that you see, and it's going to check to see if the supplicant's username and password is in the database. Now, if it is, the computer now have access, right? It has the green light to utilize the network's resources, right? And that very well mean all of a sudden it can start sending data onto the internet and receive data from web servers across the internet. All right, so that's all we've got for this module. I hope you join us the next time. Let's do a quick recap here. We just talked about wireless devices, wireless standards, and also how to secure wireless networks and the technologies that are involved there. So I hope you had as much fun as I did. Thanks again for your time, and I'll see you in the next module.